Hi, I'm Armin, and I'm head of quantitative research at RSQ Labs, and today I would like to make a quick introduction to game theory and economics as part of the DeFi lecture series. First, we're going to talk about why mechanisms matter, and this is going to be an introduction to game theory. And we're going to look at some of the typical examples you might encounter, and that might be relevant to our field. Let's start with the definition of game theory. It's the study of the ways in which interacting choices of economic agents produce outcomes with respect to the preferences of those agents, where the outcomes in question might have been intended by none of the agents. What does that mean? So we're looking at interacting choices, so the decisions that agents are able to make within a given system. It could be natural, it could be artificial. Natural one would be what occurs in the real world if you have a resource that's constrained and some people have access and some people don't. Or it could be artificial, where we set up a given market. For instance, if we set up a DeFi product and we allow agents to interact in a given way, for instance, to buy or sell certain coins or certain tokens for a price and to sell them under certain conditions. So why are these outcomes potentially unintended by the agents? This could happen if they all individually try to reach their goals, but collectively it leads to something that they wouldn't have guessed. I think the best way to show is with an example. So let's start with the 2012 Olympics badminton women's doubles tournament, and something interesting happened there. There were 4 disqualifications in the group stage due to attempts to lose the game deliberately. And if you watch sports, you would be a bit surprised probably. Why would a team try to lose a game on purpose? Usually you just want to win and come in first. So let's look what happens. The tournament is split in 2 stages. There's a group stage and a knockout stage. In the group stage, the groups are split into 4, or the teams are split into 4 different groups. And within each group, the top 2 teams get to proceed into the knockout stage. And what happened there was that in the knockout stage, in the group stage, one of the strongest opponents in the whole tournament came in second, which means that they would compete against the first of another group. So what does that mean? If you're trying to win the overall tournament, or what is most important to a team in an Olympics tournament is to get a medal, because nobody cares about who came in fourth. The only important thing is both in the country ranking, but also individually when you try to present your successes as a sports as someone in sports. You will probably try to present, oh, I won these medals at these Olympic tournaments. And what happened was, if you're the second team, if you're the first team of the group that has to compete with this team that came in second, which is a very strong opponent, your probability of winning a medal go down strongly, because in the knockout stage, only the winning team of a single game gets to proceed into the next round. So if they were able to come in second, they would not compete with this team, but they would compete with another team that came in first in another group. This was considered unsportsmanlike behavior, but on the other hand, it was to be expected if you look at how the tournament was set up. And if you think about it, there might have been some ways to avoid it. The first way is to increase the what we call utility of coming in 4th or 5th or 6th. So essentially the situation right now is there's a very high utility to come in 1st, 2nd, or 3rd. And the utility of coming in 4th or last in the tournament is essentially the same, because either way you didn't win anything at the Olympics or in the tournament. So one way to do so would be to give some prize money or points for like, let's say, the something like a World Cup, or something like a yearly leaderboard for teams who come in not first, second, or third, but also in the places after that. This would ensure that there's some incentive to at least try to come in better than last. The other way would be to shuffle things up. So if you're not certain if you're going to meet this specific team that looks to be the strongest opponent, you might actually have a chance to get a better result by competing and coming in first than by not competing and coming in, or potentially risking disqualification. So let's look at another example and a slightly different situation. So it's different in the sense that we have something called a dominant strategy that is more in favor of the side that set up the mechanism. And what we're talking about is the prisoner's dilemma, which is a typical example in game theory. And it's based on the situation where there's a prosecutor and two prisoners. And there's two different charges. There's a lesser charge and a main charge. And the prosecutor doesn't have enough evidence to convict either of the prisoners for the main charge. So what the prosecutor needs to do is to get one of the sides, or both sides ideally, to confess. And by confessing, one side betrays the other side. And so the outcome in this situation is that if both sides do not confess, they each serve 1 year. If both sides confess, they serve 2 years. And if one side confesses and the other side doesn't, the side that confesses gets to go free and the other side gets 3 years. And so let's see why this is good for the prosecutor and bad for the prisoners. Let's put ourselves in prisoner A's shoes. If prisoner A, in deciding to confess or not to confess, needs to think at what prisoner B is doing. And prisoner B will either stay silent. So let's say prisoner B stays silent. And if prisoner A, who's making the decision now, were to also stay silent, they would serve a year, versus they would go free immediately if they would betray. So in case prisoner B stays silent, it's better for prisoner A to betray prisoner B. And in the other case, if prisoner B betrays prisoner A would get 3 years if they stay silent, or 2 years if prisoner A also decides to betray. So in this case, again, it's better for prisoner A to betray prisoner B. And this is what a dominant strategy is. So irrespective of what the other side does, it's always better to go for a certain strategy. And in this case, it's to confess. And the paradox situation is that if we look at the overall time spent in jail, we're getting a result that is worse for both. So they could both, if they were both to stay silent, they would both serve a year versus the 2 years that they're serving now. But this mechanism was set up in a way to ensure that this is happening. Now, there's a few assumptions with that, of course. So there's no way to enforce staying silent. So there's no real way for prisoner A or prisoner B to cooperate in a binding way, and this is what the prosecutor is able to exploit in this situation. And it's of course important to keep this in mind when setting up mechanisms. If you're able to act in this way, it might be in your favor, but be sure that they can't make any side deals. Now, the next example we're looking at is the tragedy of the commons. This was so the commons. This example comes from, I think, a few hundred years ago, and the commons where people were more involved in agriculture, and the commons was in the setting was a field, essentially, that was to be shared by all the inhabitants of a specific area. and where they could put, for instance, their animals to go and feed. And so in the modern sense, it's a shared, non-excludable resource that benefits all users and regenerates as long as it's not overused. So in the old days, if you would put too many animals to feed there, you would essentially overuse it and then nothing would grow anymore. Non-excludable also means that you can't limit how much people are using this resource. And some modern day examples of this might be fishing or the environment. And the tragedy in this situation is that there's a rivalrous nature of this good. And this means that it's for an individual, the best strategy is to use as much as possible. So say you're a farmer in this setting, it's best for you to have as many animals as possible and have them feed exclusively or as much as possible on this common field that essentially everybody is sort of paying for, because you don't really need to pay for it as compared to any other resource to get food. And the problem with this is that there's going to be a collective action. So because everybody, because it's for each individual, it's better to use as much as possible, it's going to lead to a situation where everybody thinks this way and everybody's going to use this as much as possible. And again, the modern day scenario that's similar to this is if we look at fishing. So the fish population will regenerate as long as you don't fish too much of them. Because if you fish too much of them, they won't there won't be enough to regenerate, and at the end of the day, we'll end up with zero fish, and they'll go extinct, which is unfavorable outcome for everybody involved. But it's bound to happen because for each person fishing, it's best to fish as much as possible because this increases their wealth or their utility to the greatest extent. Now, what can we do about this? There's like best or one way to think about this is to impose some limitations, and this is possible to a certain extent in different cases. So with fishing, if you start setting up quotas, it becomes an excludable resource. You can't indefinitely fish on it, but you make sure that that it's being used in a way that's sustainable for the population. Now, what's going to happen is that individual actors will try to circumvent that, and it's difficult to find an agreement on that because there's going to be discussions of what is a fair level of using this resource. And again, this is another example of a mechanism that might come up in a DeFi setting, and something to think about and try to avoid. So let's look further in mechanisms and in game theory. There's another concept that's important. It's the concept of cooperative and non-cooperative games. So in non-cooperative games, the players will make their decisions independently. So they're trying to maximize their individual utility, and this is a situation we've seen in the prisoner's dilemma, we've seen in the badminton case, and we've also seen in the tragedy of the commons. Opposed to that, there's cooperative games where players are able to form some form of binding agreement, and with that, they might end up with a higher utility overall. So if we think of the prisoner's dilemma, if we were to extend this game to some way that they could form a binding agreement, so for instance, if they had some outside form to enforce the strategy that they choose, they could both figure out a way to not confess and to only go to jail for 1 year as opposed to several years. The binding agreement and the tragedy of the commons would be to say that there's a quota on something, or that this common good gets sold to one separate entity, and this entity manages the access to it. And this is something to think about, again, in a DeFi setting, and we'll go into that in other parts of the lecture. But these binding agreements might be happening somewhere else. There might be some ways they might be enforced, so you should take care to understand what type of binding agreements might happen around the mechanism that you've designed.